Hi everyone, welcome to Python Code Nemesis. A bit about Python Code Nemesis and this channel before we start with the first video. So I started as a developer, a student who didn't really know what they wanted. And I remember Python being my lifesaver. It's amazing what this language can do, the amazing frameworks, the innovation that everyone is doing in the world right now. And it's amazing to see all the community support in there. So, whenever we think of, changing things or writing articles on something, we also think, what if it was done before? And then one day, one of my friends said, even if it helps one person, you should do it. So that is the driving force behind Python Code Nemesis and everything that we do. So without much ado, let's get started. The first one is Python mocking with Unittest.mock. It's published in Code Like a Girl. What are function mocks? Mocks basically imitate a function and return a certain response instead of calling the function. Why mock functions? While testing a certain function, there might be certain internal functions which get called while executing this function. We don't want to execute these internal functions. This is where we use a mock. It returns a specific value to a function which we have previously defined. Which function to mock while testing? If you are testing a certain function, you'll mock the internal functions of that function so that you can just test the underlying functionality of this function and not the internal functions. There are several concepts in Python mocking. You can do the mock inline or you can call them. Using pytest.fixtures. Pytest is a testing library in Python. We will first look at calling mocks from a test config file called conftest.py, and then we will call these fixtures to our test file. Conftest.py is the generic configurations for the test. Inline mocks. The other way we define mocks is inline inside the test function. We will also look at an example for that. Input and output. Now, there's two things to keep in mind, the expected output which you define and the actual output you get by calling that function. Let's say a simple example of a function, y equal to x plus 2. Let's say you pass 7 to this function. The expected output is 9. Then you call the function in actual. You'll write the test to assert that these two values are the same. That's it. Python mock library, Unittest.mock. One important thing, having a test configuration file is very important. It makes the code look less chaotic in case you need to mock the same function multiple times. Decorators are an important concept to know when you use mocks. You can use a function decorator before the test function to include the test fixture, and the function will automatically use the mock whenever that function is called. That's amazing, right? Decorator modifies a function to behave a certain way. Let's look at writing a test this way. Create a file conftest.py and define the function mock. At pytest.fixture, def mock max function internal, return value is equal to return value. If side effect, mock patch object class name function, return value equal to return object. Return object is 0.64 something, mock.patch.object, class name, function, return value equal to return object. So if there is a side effect, then it returns the class name, function, and the return value that is supposed to come. And otherwise, it will return the return object as 0.64. Here I used a mock.patch.object to create a function mock. We create a custom function and pass it a return value. This way, we can modify a mock to return a specific mock value. Create a file mathsclass.py. There's a function maths function with a certain input. You will mock the function maths function internal function. From decimal, import division by 0 class maths class. Define maths function internal, pass in the self object and x. Return x minus 5. Maths function cells comma x. Try y equal to 4 by cells dot maths function internal x. Y equal to y. Part 2 return y. So object 1 maths class object 1 dot maths function x equal to 10 division by 0. That is the division by 0. So let's look at it. Maths function x goes into this. Then we have 4 by 5. Maths function internal. So 10 minus 5 is 5. So 4 by 5 is 0. 0 squared is 0. That should be fine, right? Yep. And this is the case where there's going to be a division by 0. So there's a small error here. So in this case, there'll be a division by 0 error. Now create a test math class.py file. So the test name will be exactly the same with the test in front of it. That's how pytest gets to know it's a test class. It's a test file. Create a class test maths class and create a defined function to test the success of the previous function. Also define a decorator by using pytest.fixture to ensure that the internal function gets replaced by the return value of the mock. So class test maths class, add pytest fixtures, mock maths function internal. Expected output 0 point this, actual output maths class function 10. Expected output equals to actual output. What is this? What's happening here? So if you go here, last maths function 10, this will be 4 by 5. But what is that returning? Is it returning 0.64001? Yep. So now that we've written a test, a few points to keep in mind which I came across while writing tests which helped in debugging. Validate the input you're passing. It should return the value of the correct return type to be used by further lines of code. Check if the library functions you are calling are called from the same library for the config file and the actual function definition of the function that you're testing. If they are different mocks will be created. So sometimes it happens that we have different modules in the code and both of them have a function which is named the same. And you use IDE and you get a bunch of options to import it from. So make sure you import the functions from the correct module so that you get the right output. So you can't import from V1 and expect V2 mock to work. Once more, testing can be checking if a certain function got called with certain parameters n times or not even once. This is to check if the function even got called. So in some cases, in some if-else statements, we do not want a certain part of the function to be called or a certain mock to not be called. In that case, this also helps. So class test maths class, test maths function with mock.patch.object, maths class, maths function internal with pytest.traces, division by 0, actual output, maths function assert call once, maths function mock assert call once with 5. So we can assert that this was called once with 5. And here we check if the mock, internal mock was called once with this value 10 as it should be. Assert called once checks the internal function was called once. There is the mock was called once with, you can pass in the parameter that the function was called with. And you can also assert respect to an actual output to be equal or not. The code for this is available on GitHub. You can try executing it and seeing how it is working for you. Next, we will be looking at access specifiers in Python and then data classes, static methods, and finally schema validation with Marshmallow. Thank you for watching. Have a great day and feel free to leave some comments if you like